All right, good morning. Welcome back to Applications of Calculus 2. On this problem, we are to construct a fourth degree Taylor polynomial from the function natural log of 1 plus 2x squared. So this one's going to be a bit of a doozy, and we're just going to go through and start this one. So the first thing we have to do is take a bunch of derivatives. Okay, so my f prime is just going to be the derivative of the natural log function. We get 1 over 1 plus 2x squared times the derivative of 1 plus 2x squared, which is going to be 4x. Don't forget your chain rule. And this is 4x over 1 plus 2x squared. All right. Yay, our first derivative is done. All right. Second derivative. All right. Now it gets to be fun. Let me go ahead and get rid of this. All right. So I'm going to leave this as it is so we can go ahead and use our quotient rules. Remember, that's f prime of x. So f prime of g, f prime times g minus f times g prime. So derivative of the first times the second minus the first times the derivative of the second, all divided by the second thing squared. Okay, and that's what we have to go with next. So the derivative of the first, that's not going to be too bad. That's 4 times the second, 1 plus 2x squared, minus the first, which is 4x. And then we have to take the derivative of the second. So that's going to be 4x. Okay, and there's a reason why I kind of left it as a product rule, or quotient rule rather, so that I wouldn't have to go through a lot of extra exponents with this stuff. So the bottom is just going to be 1 plus 2x squared. Let's clean this up a little bit, okay? So we're going to say this is going to be 4 plus 8x squared. Okay, I just factored the 4 into both of these. And then we're going to say minus 4 times 4 is 16, so minus 16x all divided by 1 plus 2x squared. And then we'll clean this up a little bit. So this is just going to be 4, because we only have that, plus 8x squared minus 16x squared. We're going to say this is a minus 8x squared, all divided by 1 plus 2x squared. Okay, let's set that aside. That's our second derivative. Okay, two more. F 1, 2, 3 prime. Okay, so again, derivative of the first times the second, right? Minus the first times the derivative of the second. So the derivative of the first is just going to be 8 times, we're just taking the derivative of this 4 minus 8x squared. Okay, that's just going to be minus 16x. So that's the derivative of the top times the bottom, 1 plus 2x squared. Okay, minus the top, 4 minus 8x squared. Okay, times the derivative of the bottom. So we're going to say this is 1 plus 2x squared raised to the 1 power times the chain rule here. So it's going to be a 4x, right? Because the derivative of the inside. And then we're going to say divided by, okay, so that's going to be all of this business here. All right. And we're going to say 1 plus 2x squared, and we're going to square it, and we're going to square it again. So that's going to be to the fourth power. Let's go ahead and simplify this down a little bit. That worked out pretty well last time to give me a smaller derivative. Let's see if we get lucky with this again. All right. So we're going to say, hold on for a moment. Do I want to multiply this out? Not really. Could we do it? Mm, Just be safe. Let's go ahead and say off to the side here, 1 plus 2x squared, just to kind of multiply this out. This is going to be 1. So all I'm doing is saying this. I'm saying 1 plus 2x squared times 1 plus 2x squared. We get 1. We get a 2x plus a 2x. We have a 4x squared here. And then our last term is going to be a 4x to the fourth. All right. So we have minus 16x. Put this in here. We have 1 plus 4x squared plus 4x to the fourth. Okay. And then minus, and we'll come back to this piece. We'll go ahead and clean up this. I see a 2, I see a 4. So 2 times 4 is 8. There's only the 8 here, so we have 8 here. And you know what? I might go back to leaving this as 1 plus 2x squared, because here's what I'm looking at for this. If I pull a 4 out of this piece here, okay, so there's a 4 and a 4 here. I've got a 4 here, and then here is a 1 It's a minus. Okay, that's not going to work. Okay, so nope, we're not going to do that. Let's leave that alone. All right, let's leave that alone. So here, my 2 times my 4 is my 8. Here I've got a 4 minus 8x squared. And then we have a 1 plus 2x squared raised to the first power. All right, and I'm trying to get through with some of this. I think I forgot an x here. So we have an 8x sitting here. All right, and then all of this is going to be over. And we're definitely not multiplying out this bottom. Don't ever multiply out the bottoms if you can't, if you have to. And this is going to be squared squared. So instead of 1 plus x squared, 2x squared rather to the fourth power, this is going to be squared. So 4 times 2 again is going to be 8. Okay, so we're going to be doing that. All right. Now, let's see if we can't clean this up a little bit. This is going to be a bit of algebra that nobody wants to remember how to do, but let's see if it makes it a little bit easier for what's going on with everything else. I know that 4 times 16 is 64, so we're going to say this is negative 16x. Okay, that's the first one. Minus 64x cubed. 1 plus 2 is going to be 3. And we're going to say minus 16x to the fifth power. All right. And now we have to go ahead and deal with what's going on over here. Right off to the side here, we're going to say I need to say 4 minus 8x squared times 1 plus 2x squared. Okay. And I'm sure there's better strategies through this, and you are welcome to use them. I'm saying this is how I'm saying it. I'm trying to do this in a way that people can follow. So there's other ways that we can kind of figure some things out. But again, I think factoring this 4 out would have been a better idea, but we'll keep this. Okay, so we're going to say we've separated this little bits here. We have this minus 8x here, but we're going to hold on to this thing here. So we have minus 8x, and it's going to be times a thing that we're going to come up with after we've multiplied this whole bit out here. So this is going to be a 4. Okay. We have a plus 4 times 2 is 8x squared. We have a minus 8x squared for the next term here. And then we have a minus 2 times 4 is 16, minus 16x to the fourth. I'm kind of glad that I multiplied this out a little bit because the 8x squared and the negative 8x squared cancel. So I'm left with a 4 minus 16x to the fourth. 4 minus 16 x to the fourth power here. All right. And again, I haven't gotten to the bottom of this thing yet. We're still working through this. So what we have here is we have a negative 16x minus 64x cubed minus 16x to the fifth. 8 times 4 is going to be 32. So we have a minus 32x here for this first term. And then 8 times 16, give me just a moment, and we'll go ahead and pause this for a second. All right, there we are. Got a calculator. 8 times 16, we got negative times negative, so it's going to be a positive. So we end up with 128 x to the 1 plus 4 is x to the fifth. All right, now let's see if we can't clean up what's going on here. Oh, by the way, this is all over. All right, this is all over 1 plus 2x squared raised to the eighth power. All right, and this is our third derivative, I believe. Yes, one more to go after this. So let's clean up what we have. We have a 16, so I'm going to say, here, look at this. Let's go with this. As far as my singles go, we have a couple of singles. So we could look at that and we say, okay, 32 and 16. Okay, we'll just double check that. 32 plus 16, they're both negative, so that's okay. So we have 48. All right. So we're both negatives. We have negative 48x. That's our first ones. The next power up is x cubed. I only have one term that has x cubes in it, so let's go ahead and deal with that. So we have 64 x to the 3. All right. And then I've got 16 and 128, and those are both x to the fifth. You could see the fact that those look like this. So we have 16x to the fifth here. We have 16x to the fifth here. All right. Let's get rid of you. All right. So we have that going on there. Let's go ahead and just deal with this. X to the fifth here. Okay, so 16 plus 128, again, they're both negative. So we'll go ahead and deal with that. So we have 16 plus 128. All right. 144, we'll go with that. Okay, so this is going to be a minus 144 x to the fifth. And this is all divided by 1 plus 2x squared raised to the eighth power. All right, and this is my third derivative. This is my f triple prime. Okay, you have to remember this going back. The fun thing is that when we put 0 in for all of this, we're going to get 0 over 1. So this is all going to be 0 when we're done. So it's like, why are we going through all this work to do this? You'll see, because the next term will actually have a value in it. So that's why we have to go through all of this, because we have to get the proper coefficients for everything. So yeah, this one's going to be a nice 0. F3 is going to be 0. We'll go back and we'll plug in zeros for all the other parts of it when we can. Okay. So we'll go ahead and do that. All right. So that's my F3. Okay. F4. Okay. So again, we're going to say the derivative of the top. So we have minus 48, 3 times 64. Okay. 3 times 64. It should be like 192. There we go. 192. Okay. Minus 192x squared. That's taking the derivative of this term here. 144 times 5. Okay. Times 5 equals. So I got 720 for that. That's interesting. Okay, so that's going to be minus 720 x to the fourth. So that's derivative of the top times the bottom. So that's 1 plus 2x squared raised to the eighth power. Okay, minus the first. So we're going to say minus. Actually, I'm going to factor out a negative sign out of all of this. So we're just going to say these, notice that all of these are negative, so we're just going to say negative and negative, so plus all of it. So plus 48, so we're going to say 48x, so derivative minus the first, plus 64x cubed, plus 144x to the fifth, times the derivative of the bottom. I'm just going to do that down at the bottom here, so we're going to say 8 times 1 plus 2x squared raised to the seventh power times 4x. So we have to do the bottom here. So times 4x could be the product rule. Okay. So that's my derivative of the bottom. So it's all of this times this piece over here. We'll go ahead and make a new summary chair here, summary little spot. So we're going to say this is negative 48 minus 192x squared minus 720x to the fourth, all times 1 plus 2x squared raised to the eighth power. And we're going to say plus, fortunately, this is the last one, right? Uh, 48x plus 64x cubed plus 144 x to the fifth, okay, times the derivative of the bottom. 8 times 2, 8 times 4 rather, is going to be 32. So this is the first times the derivative of the second. So this is 32. 1 plus 2x squared raised to the seventh power. So the first times the derivative of the second. And this is all divided by, all right, 1 plus 2x squared. And it was to the bottom here, it was eighth. So it's going to be squared again. So we're going to be a 16 down here. Okay. So that's our fourth derivative. Here's the fun part, because now we have to evaluate all of this at 0. Aren't you glad we aren't multiplying it, doing it at 1? But now we're going to evaluate f of 0 for all of our derivatives. So after all of that work, to get all of those coefficients, we're going to go all the way back up here, and we're just going to start plugging in zeros. So my 0th derivative, we plug in a 0 for x. We end up with the natural log of 1. The natural log of 1, so this is natural log of 1 plus 0, which is equal to the natural log of 1. We get 0. Okay, f prime. Okay, we're going to go back up here to remind us what f prime was, all the way back up here. And we're going to say, when we plug in 0, remember this was our f prime up here? Our f prime, plug in 0, we end up with 0 over 1, so that's 0. Okay. equals 0. Our f double prime, so we'll go ahead and say f double prime of 0. So we'll go all the way back up here and collect our f double prime. Okay, and our f double prime, we plug in 0 for x. We're going to get a 1 plus 0 squared on the bottom. So we're just going to end up, it looks like a 4. So on the f double prime, we have 4. Okay, f triple prime of 0. So we'll go back up to where f triple prime is. Okay, I'm sorry, I don't mean to do a whole lot of motion here for us. But f triple prime, if we plug in a 0, we get 0 times this stuff minus 0 times that stuff. So we have 0 on the top, a 1 on the bottom. So we end up with 0. Okay, after all of that, we end up with 0. And finally, my fourth derivative, okay, aren't you glad we don't have to do a fifth, equals, and then I'll go ahead and plug in my fourth derivative. So if I put in 0 here, we get 0 and 0 with a 1, 0, 0, 0. So it's 0 times a whole bunch of stuff. I don't really care what the 32 times 1 is. It's 32, but it's going to be times 0 at the end of this thing. On the bottom, it's going to be a 1, but it looks like everything up on the top just comes down to minus 48. All right, so minus 48. All right, now we're ready to put this together as a polynomial. So remember, this is going to be 0 times x to the 1 over 1 factorial. This is going to be x squared over 2 factorial, x3 over 3 factorial, and x to the 4th over 4 factorial. Yeah, 24. All right, so as we go through and do this, my 0th derivative was 0. So times x to the 0, which is 1, over 0 factorial, which is 1. So we're ending up with 0 plus 0. So here's my fourth degree Taylor polynomial. Okay, so we end up with our 0th term plus our first term plus our second term, okay, which is going to be 4 over 2. So we're going to have a 2x squared. Okay, we have a third term, which is 0. 48 divided by 24 is going to be 2. So we have a minus 2x to the 4th. And our fourth degree Taylor polynomial is simply 2x squared minus 2x to the 4th. And that's all we really need to do with that, thank goodness. And that's our fourth degree Taylor polynomial to approximate the natural log of 1 plus 2x squared. Okay, let me go ahead and type this thing into a value so we can just kind of approximate and see what's going on here. So let's go ahead and do this. We have, let's see here, let's look at a Desmos. Here we go. Okay, we don't really need to do this, but I always like to check to see what's going on here. So we have y is equal to natural log of 1 plus 2x squared. How about 2x squared? All right, and again, we're going around 0 here, so that's fine. All right, and we could look at that, kind of scroll in to see what's going on, like kind of a cup type of a thing. And let's go ahead and look at this. This is 2x squared minus 2x to the 4th. So we have 2x squared minus 2x to the 4th power. It's actually not too bad. I mean, it does kind of approximate it right around 0. Okay, and again, this is going to be a problem, but if you did have problems with or a natural log might be undefined, that this polynomial is going to be just fine, but it does kind of approximate it pretty well. So hooray, that looks pretty good. So very good. We'll go ahead and stop it there. And I'll say thank you very much for watching the video. Thank you for being the patience with going through all of those derivatives. I know you can do it, but that's pretty much how you do a problem like that. And good luck studying for test. Thank you very much for watching, and we'll see you on the exams.